I'll just review where we had got to. We kind of covered Workspace primarily, which is a great place to start. We kind of covered the fundamentals there. Now we're moving into Studio. And we had just gone through the Studio UI at the highest level. We did have a look at the structure map a little bit. I got a bit into tagging and filtering and grouping and so forth. You'll see some of that in action now. We haven't really covered the Studio views. I just mentioned that they were there. So I'm going to go through those one by one. They're sort of useful, well, views into the structural model that Studio maintains. So you can get all kinds of interesting information there. I'll go through them, and they're not sort of what we would consider mainstream usage there. They tend to be used sort of as needed for different purposes. And then we'll get into the restructuring side of things. By restructuring, I guess we kind of mean refactoring. We differentiate restructuring because what you're really trying to do for the most part is, it's like refactoring. You're not going to change the functionality, but you're trying to reorganize your code base in order to simplify it. So I'll show you some of that in action. And what we're doing as we're doing that is we're reducing the coupling, usually. That means we're sort of looking at the coupling between, let's say, packages. At the same time, we're probably increasing cohesion, which is where we're within the packages themselves, we're trying to gather together things that use each other. So they're more cohesive. And then I'll show you another type of restructuring. The first one I'll focus on is really disentangling. So it's really, as I had mentioned before, it's kind of improving the raw materials of your code base, trying to get the structure a bit more clean, easier to understand. Extracting modules continues from that theme, I suppose, but it's more directed. It's typically where you would have a very large module and you want to break it up into smaller modules. Okay. And then I'll show you how we can share actions with Workspace and build. And we'll start the next step, if you like, which will be how we create specifications within Studio. So let's move across. So if you remember the big picture, if you like, of the Studio user interface, you've got four main tabs. You've got the structure tab. That's kind of like where you're going to spend a lot of your time when you're restructuring. I would recommend this is the main place you're going to go probably when you're doing dependency analysis. It's a general purpose place that lets you do all kinds of cool things. In particular, it lets you kind of drill into your structure and discover the dependencies by selecting things. There's various viewing options for highlighting specific structural patterns and anti-patterns, if you like. The overlays, this is where we're going to create a structure spec and architecture diagrams. These are types of specs. And then the views, which I'm going to look at now. I think I touched on this one here, which is the complexity view. And this, again, focuses in on the basic concepts of where is the structural overcomplexity in your code base. You can drill down here and sort on that to find out where is the code. The length of the blue line indicates the amount of code in each module. The red line indicates how much of that is considered overly complex. And as you drill down, this list of problem items, or the items with overcomplexity, is filtered. So I can see just the items in the core.com area, headway. As I'm drilling down, this list is getting shorter because I'm limiting the focus of the list. And then this pie chart sort of indicates where is the source of that problem primarily. So if it's fat, at what level is it? You can see there we've got some fat at the package level, some at the class level, and some at the method level. And I can filter based on these here. So I can just see the fat methods or the fat classes, for example. This is a very useful view for that kind of overview. I often would dig in if I'm starting working with a client. This is a great place to start just when you don't know much about the code base or you're not as familiar with it, and you'll probably find even with your own projects, it's a great place to just get an overview. Where is the code and where is the complexity type thing? Okay. So now we move on to the composition view here. The composition view is showing you composition. It's letting you drill down on the structure to get a graph, a nice graph here of the internals of specific containers, if you like. So here you can see, you can double click here to drill down into any of these. This is the top level view. So it's a nice dependency diagram. Generally, it's a good idea. Keep maneuvering these viewers here. If you're not using the breakout, you can kind of reduce it down to get it out of the way. Or at any point in time, if you want to maximize the screen here, you can double click on anything just to kind of maximize a particular viewer windowlet within the UI. And it's showing you the dependencies between the various modules at this level. So at the very top level, I'm seeing the dependencies between the modules and I guess the weighting. So the number of references between any of those. As usual, you can click on any of these to see what are the actual dependencies that flow between two modules. Okay. As I drill down, let me go into the core here, okay, there's not much there, not very interesting. Then it splits out into core.headway and core.com.nalpiron. Okay, the actual location we're at is at the top here. When I go into headway, things start getting a bit more interesting. I can see I've got that cyclic dependency in the middle there and the various dependencies around. We can switch off. There's a sort of a magic wand here, which causes for the tangles to be highlighted. In very large graphs, you'll see it also groups together things to help you kind of understand if it's a very large, probably fat location in the composition, you'll be seeing cohesive clusters within it with this option selected here. So you can switch it off just to see the basic dependencies here, or switch it on to highlight the tangle. When you select any of these items here, you can see it grays out anything that's not used directly by the thing you selected. So it's a good way to kind of, I suppose, just drill down and get a feel for, how are things looking in this nice graph representation. You can also view any graph as a matrix. If you like the dependency matrix representation, this is how it looks. What it's doing here is it's listing all the items in their layers here on the left-hand side and also across the top. And the dependencies flow down the columns, if you like, to the rows. So this cell here of 8, for example, that indicates that this package code map uses metrics 8 times. And if I select there, the dependency breakout shows me all of those 8. So this can be useful. Some people like to use the matrix. It's there if you want to see that in that form. Okay. And as you drill down, you're going to be getting down into the classes themselves. You're seeing the dependencies between the methods and the fields within the class. All great stuff for comprehension as much as anything else. The next view I want to show you here is the slices. The slices view lets you see the code base, as you can see here, at the various levels of composition. So in the case of Java, right down at the bottom of the structure, not quite, because you also have methods and fields, but for the purposes of slice, down at the bottom level, you're going to see the outer class level. So that all the code base is made up of classes. And then they are composed into leaf packages. And then this is sort of to allow you to kind of walk up the code base to see it in levels of increasing abstraction. Okay. If I look then at, let's say, this is a particularly useful one. If I look at the outer classes here, you can see I've got 2 subtabs here, and one of the items in the tangles tab is currently selected. What this is showing me is if I were to take all of the classes and throw them into a big dependency graph, within the outer class, these are the tangles of classes at that level. So the biggest one I have is this group of 26 classes that are cyclically dependent. I've got one of 23, which is a bit easier. You can see that, I guess. That's a good example in the sense that it fits in one diagram. But this is sort of highlighting areas where the classes themselves are reasonably complex. And it is also showing you the number of parents. So in the case of Java, parents are of classes is packages. And you can see here, because this is something that we follow ourselves, is we make sure our packages are acyclic. If they were not acyclic, then you'd see more than one parent here. And that would be significant, structurally significant if that was the case. It's always interesting to know, and it is one of our key measures that will appear in your dashboard, is the biggest class tangle in your code base. Often in a large code base where you haven't been monitoring this stuff, there could well be a very large class tangle buried in your structure. And it's kind of hard to see in the other views. That's why we highlight it here. So having a look at this one here is often very useful. And that could be hundreds or thousands of classes in a massive class tangle. That would indicate a major problem in your code base. Because that means that is a whole load of code where it's going to be extremely brittle. Any changes you make within those hundreds or thousands of classes is likely to have a lot of impact. Okay, so let me just show you something. If I go to this one here, the tangle of 15, maybe this one here. Okay, let me grab this one here. I'm going to sort of use tagging and I'm going to make a change. I want to spread this class across multiple packages so that we can kind of see the effect of doing that. So currently it's all in one package here. The number of parents is 1. So I'm just going to tag that there. And you can see all of the classes here are now tagged. Let's see where they are in the structure. If I drill down here, they're all in this C view area here. I'm going to switch that off for a minute. And within here, they're all within browser. And there they are. There's all of those classes. Let me just group the tangle there. There's that tangle, right, that we just highlighted, that we spotlit, let's say. What I want to do actually is I'm just going to move some of those into another. I can simulate this in the model. So I'm just going to grab a couple of these here and put them into the metrics package, and maybe another couple. I'm just command clicking here. I'm going to move them into, let's say, the pages there. Okay, so that underlying class tangle of 15 is now spread out across 3 packages. And that becomes really clear now when I go across to the view here. If we go back to here and we go, it's one of these 15s, wasn't it? This one here, I guess. You can see here now the number of parents is spread out here across 3. That's changed to 3. And I can group by parent here. And I get a visual representation then of this big class tangle. All of these classes are cyclically dependent, and the containing leaf packages is visible here. So that can be a kind of useful way to do it. I'll say no more about the tangles. I think you get the gist from that. The groups here is a bit different. I'll show you here what exactly it's doing. And this one here that it's selecting by default is the main group of basically 2,500 classes. So that's what you'll usually have. You'll have a main group. You're putting all of the classes onto a big, if you imagine, right? We've got a big class dependency diagram. And within that big class dependency diagram, some of those classes are not dependent on the others. Okay. And you can see here, it's absolutely massive here. There's not much use generally in showing the main group class slice. That's just not particularly interesting, generally speaking. It's much more scalable as a matrix. and I click the fit here, there are all kinds of things that you can look for, these vertical lines and horizontal lines, and they have particular meanings and stuff, which you may or may not find useful one day. But what are almost more interesting are these ones here. Let me go back to a dependency graph visualization here. And let me switch these guys off here. Here we've got the orphans, first of all, okay? And then we've got some orphan groups. So orphans are individual classes that do not depend on any other classes. They're all lonely in the code base, nothing's using them, and they don't use anything else. They may or may not be, and maybe if you're using reflection, they are actually used, but they're interesting in that respect. But you also have some orphan groups here. So these are groups of classes that are interdependent. So these 4 classes here do have dependencies between them, but the group of 4 has no other dependencies. So that's why finding orphans is kind of interesting, and that's useful in its own right. But you also need to find out that, like this one here, swatch panel is not an orphan because it has dependencies and other things depend on it. But those 4 items together may be redundant. They may be something that you can pull out of the code base. And as you know, every bit of code that you can pull out the code base because it's no longer needed or used means that your code base becomes that much simpler. There's less testing, there's less maintenance, there's less confusion, etc. Okay, so that's the slice view. Collaboration view is a simple way to just understand dependencies. Okay, so if I click on the core here, you can see most of the stuff on the right-hand side. In fact, all of the stuff on the right-hand side is now grayed out. That's because if you remember, core was at the bottom level. It doesn't use anything else. Okay, so let's pick another one here, build tools. Build tools does use a bunch of things. You can see it uses core and a few other modules here. And I can drill down now to see what is it inside core that build tools uses. Okay, and as I drill down here, I'm going down into here, I can see it's using all of these things. What is it using, for example, within brands? Using everything there. Foundation here. Within foundation, then it's using a subset. You can see the other stuff is grayed out. The things that are not used by build tools is grayed out. And I can filter these lists down here by selecting something here. So in this case, I've said, now I'm seeing all of the things within build tools that use things within high view. And that's the list here. So it's a general purpose way of understanding the dependencies between the whatever. You've got the superset of the code base on the left-hand side and on the right-hand side at the top level here. And by selecting things on the left or the right, you can understand the dependencies between those 2 items. Okay. I'm going to come back to class hierarchy. I'm going to go across here to notables so that I can find a good class hierarchy. I'm going to look here at the class depth here. So this just sort of gives me the classes that have a lot of inheritance from them. That's what the depth is all about. And so now if I go to this one here, you can see the number of child classes here is 18. I can, let me go here. Oh, I did a double click. I'm sorry. Let me go back here. I should be able to go. Oh yeah, you have to actually click on the node here, not on the row. And now I can go to the class hierarchy of that. Okay. And I can see that inheritance there. So the class hierarchy will often be something you can go to. You can jump between these different views from other views. So if you were drilling down and you were trying to understand something or analyze something, perhaps in the levelized structure map, you might right click on it and say, go to the class hierarchy view for this particular class. And it will give you this kind of a view. You can also drill down here, but then you're trying to find things, like if I click on something here, Yeah, there you go. There's another one. And, you know, once you get down here, you can find them. And then you can recenter. So you can double click on anything in here and it becomes the item for which you're looking for any inheritance. So it lets you walk inheritance structures, basically. The call graph, as you might suspect, does what it does. I wonder if I can quickly find something that has an interesting call graph. And the problem here is that finding something that has some dependencies. Oh, good, I found something. Here is the call graph. By default, the call depth is limited to 2. But if you see, if I go to 3 here, it's growing out to the left-hand side. So you can grow that right out. So you can see get brand there. And when you mouse over any of these items, it gives you information about which class and package and stuff that is in. So it gives you a way to chase dependencies. And at any point in time, you can double click on something here and that'll become the center of attention. And you see a call depth to the depth of 4 in both directions at any point in time. So that's useful in its own right. Let me show you some of the other notables then. There's some, so things like class tangles, we've sort of looked at that. Split packages is an interesting one here. Let me show you what a split package is. If I go to the, let's say the LSM for util, there it is. Let me expand that. And I'm going to combine that to highlight what this split package is really telling me. Let me collapse this other one out of the way here. And here we go. So we're looking at this. I'm going to just isolate that. If you remember, I can filter to just isolate that. I can see here, okay, I'm not seeing anything particularly interesting here. What do we mean by a split package? And I could figure out something about a split package by going through. I could perhaps show all the dependencies here, and that might help me kind of figure it out, but not really. It's quite hard to figure out what that is unless I click this button here. So this shows me the orphans and orphan groups. And what it means is there's a lack of cohesion in this package. You've got a group of 2 here that has no relationship with the rest. Another group of 2, a few groups of 2 here, group of 3 that has no dependencies on the other classes in here. And then we've got the main group in the middle here of 20. Okay, and then we've got a bunch of orphans. The ... icon here indicates that they're just standalone icons. They all go into the last group there. Okay, so you have a lack of cohesion here. In the case of a util package, that might be perfectly appropriate. But in other cases, it might be, if you like, a code smell that might indicate you've got a bunch of stuff grouped together that actually doesn't depend on itself. Therefore, maybe it would be worth moving some of those groups over to where they have other dependencies. So if I clear that, I wonder if I can find a nice example of that here. Maybe one of these groups of 2 here. It has no other dependencies, that one. Here we go. Let me collapse this down here. So this group of 3 here, maybe I could move it into widgets where it does have dependencies, for example. Okay, so I would expand here and the group of 2. I guess it was the group of 3 I was looking at. You know, I might decide, well, here's the lowest level package that it has dependencies on. Just grab it and, you know, move it over there. And then I would find if I go in here, then those things that I moved across, that group of 3 now is in amongst its friends here, if you like, things that it does have immediate dependencies with, and that might make it easier to understand. I'll say no more about that. Are there any other notables? Changes is an interesting one. I won't talk about changes just now, but you can see there's package changes and new package dependencies and that type of thing, where you're comparing it against a previous build. That can be very useful there. Fattest classes, there's other ways to find those things. Mixed packages, this is sort of something that some people value. If I go to, say, widgets here, filter on that. What that means is that I have a package here that contains a mixture of, here it is, accordion. It's got a mixture of packages and classes. And sometimes you might find that sort of mix of granularity, it might be as well to tidy the other things away so that we have a bunch of packages in here or a bunch of classes in here, but not a mix of both. So they're not necessarily a problem, but they're things that you might find useful. Okay, so that's the views. I think we've gone through all of the views here. I'm going to come back to the structure here, and actually I'm going to open up a different project here. What I want to show here is, in a simple example, I'm going to go through and disentangle this particular project here. It's a bit of open source that we found. And I'm going to just use drag and drop and the various features that you have in the LSM in order to disentangle this code base here. Okay. So the first thing I'm finding here within the top level, this tangled package here, and you can see I've got util, net, and faces are all in a cyclic relationship. How might we go about disentangling this? Okay, so first of all, let's look in util, because a common anti-pattern actually is that something called util or utilities often is used by a lot of the rest of your code base. And then in some cases, the code that's in the util package starts using stuff that's outside of the util package, and that causes a lot of cycles to be formed. So in this case, I can see that these are all orphans. They don't have any other local dependencies. So I'm going to just say, well, this server utility here has a two-way dependency on faces. Let's just move it up to faces. This thread local utility, likewise, two-way dependency on faces. Let's move it there. It's not using anything else in util. Nothing else is using it. Why don't we just put it in there where it seems to belong? And that has now freed up util from the cyclic dependency that was there before, from the tangle. And you can see on this chart here that the percentage tangled of this project now has reduced slightly by several pixels to the south. So we made a little bit of progress. Let's take a look at the rest here. If I look inside this net messaging area here, I can see that the feedback dependencies are coming from two locations, sort of, right? One is from a class that is within a cyclic dependency of classes here, within a tangle of classes, and the other is from this folder. I mean, probably HTTP and these message service clients and that type of thing probably do belong in the messaging package. So there would be other considerations, but I'm ignoring that for now. And I'm just going to grab HTTP and I'm going to say, look, move that up there. And now I could sort of take this one here and move it up, but I know it's within that tangle of classes here. So there's no point really just moving that. If I do it, I can move it up here. That's grand, but obviously because it's in a cyclic dependency here, these three classes always have to go together. So I'll undo there and I'll just grab all three of them and move them up there. And that has disentangled things for me nicely, okay? And that worked out quite well because of the layering. I had some things that were sitting up at the top layers within messaging. If I had grabbed this one here and moved it up here, you can see there are a load of dependencies above it. It's in the middle layer here. So that's not going to work as well. I'm going to create all these feedback dependencies. So that wouldn't make sense. So I'm using the layering as I'm going there. Okay, so where does that leave us now? Now we've still got, okay, we've moved a bit further south here, but we still have a big problem. What is the big problem? Here it is here. I've got this tangle here, and most of the code must be in this area because most of my code base is still in a tangled area. So I'm inferring that that's it there. Let's take a look now at how we can disentangle that. First of all, I see all these dependencies going in and out. I only care about the internal dependencies when I'm breaking tangles, okay? So what I'm going to do here is I'm going to isolate that tangle just to simplify what's in the user interface at the moment. I'm noticing here again, I've got util sitting here, okay? Why is util using other stuff outside of util? Well, that's the problem. So I'm going to just grab that. And then the core utils, it has an outgoing dependency there. I'm going to just move them out of there for now. We can put them in their final location later. But again, that has left util has fallen out of the tangle because it no longer depends on anything that is in the tangle. So rule of thumb, and what you're looking for when you're disentangling your code is that you want to make it so that there are a few minor changes that I can make to the packaging. So move a few classes around ideally, so that the package now either uses stuff in the tangle or is used by stuff in the tangle, but not both. And that's what I did just there. Okay. So now let's refocus here. So we're going to filter just on what's left of the tangle. I'm going to do it this way a bit different. Here I'm going to find out anything that has incoming dependencies, which are these feedback dependencies, that one and that. Actually, just this one here. I can see here, if I remove, these other ones are going over to this package here. If I move that out of there, then facelets has fallen up out of the tangle. And I can keep doing that kind of thing. So let's focus on that one there now. Now I'm left with a fairly big group of stuff. And actually, if I drill into this one here, I'm seeing, oh, I've got tangles within tangles, and I spend a bit of time. There probably are a few places where I can tidy up and do the sort of things I've been doing. But let's say I get to the point where I say, you know what, this whole packaging here is not right. I might take that view. And what I'm going to do here is I'm going to wrap that tangle now into something. I'm just going to call it core. And then I'm going to expand core. I'm just making that a bit sort of permanent. I say this is a whole area of very cyclically dependent stuff. And what I'm going to do now is say, get rid of the packaging. And I can do that by flattening that to the class level. And now I could start grabbing things here and wrapping those. So here I've got, I don't know what I want to call it. I could wrap that. Wrap just means put it into a higher level container, which is a package in the case of Java classes. And that will be blocking stuff, maybe. Okay. And there's my blocking stuff as at the top. And I start pulling together a meaningful structure. And as I'm doing that, I'm keeping each class tangle within a single package. And I'm making sure that the new packages that I create are not themselves cyclically dependent. And there is actually, if I undo that, I'll show you a quick trick for doing this. There's another thing you can do, which is you can group here, tangles and cohesive clusters. And now these ones here give you a good suggestion as to how you might group together, you might repackage this area so that each package here, let's say these groupings here become packages. They all are nicely coherent and they have nice inter-package dependency relationships. Let's put it that way. So there won't be any cycles, basically. You can see what happened there when I flattened out that package, that area that was cyclically dependent. I did indeed reduce the percent tangled significantly, but I also increased the fat. So that's typically what will happen, because now I've got a lot of classes in one package. So flattening out isn't a solution. We do need some packaging in order to constrain the complexity at the package level. Okay, I'm going to leave that there in terms of actually doing refactoring, but I'll show you an end result, if you like, just for closure on this. You can see here, I did a bunch of changes. I did that kind of thing for a while. and I gradually reduced the tangles down. That's where I flattened something, I guess, and then I repackaged some stuff. And eventually I got it down to, at least I removed the cyclic dependencies there. There's still some fat. The fat, in fact, is all here at the method level. So you can't restructure in Studio method level fat. You need to go into the code. And like we did before, you're going to take some of those high cyclic complexity methods and you're going to take out blocks and you're going to do an extract method kind of process. And that's the only way to deal with those. But we at least got rid of the compositional complexity, if you like. Okay. Now I'm going to show you another aspect of restructuring where I want to extract a module from an existing module. If we take a look at the complexity view here, we can see, and I bet you most of your projects have something similar to this. You're going to have one or two or a few modules that are very large. Java tends to do that to you. It sucks classes into these monolithic modules very easily. It tends to do that. What I want to do is start the process of breaking out this core module here, okay? And what I want to do is, if I look inside core here, I can see I've got this nalpiron subpackage inside core. That is our third-party licensing there. So I want to pull out the licensing aspect here of the core module. So I'm going to do that by, I'm going to add a module here. So I'm going to create a new module called licensing. Okay, let me just switch this off so that it appears. Let me just switch that off too. We can see there. Okay, where did it go? It sits down at the bottom row because it has no dependencies at the moment. It's just an empty module. And then I'm going to grab the nalpiron package and drop it into licensing. Now, let's have a look at what happens there. First thing to notice, when you drop code in the LSM onto a module, it will preserve the complete package structure of all the classes that it moves in there. So although I moved in the nalpiron package here, it retained the com.nalpiron package structure there. This is important. If you follow this process that I'm showing you now, you won't need to actually change any code, not even import statements. Because what you're doing is you're moving code as it is today into a new module so that you end up with an acyclic structure. And then you just need to join up the errors that we have here. You can see here, there's a dependency here that's a problem. Why is that a problem? It's because there is no core to licensing include, right? There is no module to module dependency there. Now, in the case of Java, we're sort of replicating what you are probably using in Maven or whatever, where you have Maven modules, which are probably implemented as IntelliJ or includes projects or modules. And you have to tell your IDE and or Maven the core is allowed use licensing. And so there is a missing module level dependency here to allow for that. Okay. And the way I do that is I go module allow. Okay. And then I go here and I go module allow. It's actually a shortcut, which is add all missing requires dependencies, which will do that for you. Okay. But that's how you do it one by one. So now I have this situation. However, it's often the case that it's not quite as simple as that. What I pulled out was something at a low level in the core area, so it had no other dependencies. So let me just go into util license. There's actually more code I want to pull in. I want to pull in our own internal API to the licensing area. So that's these interfaces. Command, license writer, maybe that one there. And let's say license exception here. I want to pull those into the licensing module too. So I'm going to do that. And now we have a problem. Let me collapse this away. The problem is that we can't actually do that yet, because as it stands, there is a dependency from something in here. And let me just switch this one off here just to make it a bit clearer. And I'm going to maximize this here so we can see what we're looking at. There's actually a bit of code. One of the items we moved into the licensing module actually has dependencies on something in the original core module. And we can't have cyclic dependencies anyway, even if we wanted them, within Maven modules. So that is a problem there. Now, there are a couple of other problems that we can fix right now. So let me show you what they look like. That is these other, because we moved some of the core code into licensing here, other modules now are depending on something in licensing, and we haven't allowed for this, and I guess this dependency here. So what we're going to do is we're going to just select those, and we're going to allow those. That bit is easy, right? We just need to add the module to module dependencies. This one here, however, we can't do. We can't have cyclic dependencies because we already have one from core to licensing here. This one here is not going to be a flyer. So that's actually an error. Now, I'm going to just save this, and we're going to jump across to Workspace, and I'll show you why this is important. If I go here, and I load up this one here, just loading in the same project now. Oh, by the way, you need to make sure that this action list here is shared. You click the share button there. And then over here, you'll notice that there is apply actions here. So that is selected over here. So I'm saying I want to actually see the target architecture. I know I'm not there yet, but actually what I want to do is fix some of these violations to the target architecture. I'm going to have to fix these in order to make advantage of making code changes with the help of the compiler. I can't yet create this licensing module here and move all of the code that I just specified to be moved, because as soon as I do that, it won't compile. But because I'm using this simulation effect, this is sort of fairly advanced Workspace Studio kind of concept, so stay with me here. Because this code has not yet been moved, licensing does not yet exist in my current project, okay? It's not there yet. But the code that will end up there is in here, and I can navigate to it. So let's just have a look. Where is that? So somewhere in licensing exception. Oh, well, actually, I can go from this one here if I wanted to. There is a requires violation here. Let me just click on that. It takes me straight to the problem here. And once I join up with my connector, I out-click here. Let me get that out of the way. And I can see here is the problem. Now, this is fudged up, so it's easy to fix in demo time, okay? I'm just going to comment this out. And then I'm going to do a quick refresh over here. And you'll see MAC address will disappear. And that violation has disappeared. See the green minus minus, that indicates that that's gone away. So what I'm doing here is a very simple example. There was just one problem dependency. That could be hundreds of problem dependencies where I want to move a bunch of code across to a new module. If I were to just do that in my IDE, then I've got a world of pain because I have all of those problem dependencies to fix before the compiler can compile the result. However, if I invert the process there, if I invert the sequence and fix the code level dependencies so that they match the target module architecture that I'm aiming for, once I have gotten rid of all of those feedback dependencies, all of those module violation dependencies, I can then move all of the code that I want to move into my new module. I go ahead and create the new module. I create the module to module dependencies, and I move then all of the classes that I wanted to move into the new module. And typically that process might be something like not deleting individual methods as such, but what I might well be doing there, and a more common process for doing this, is that actually I'm going to create an interface module for my new module. And I will just do it that way, so that instead of having a direct call on a class, I would create a new interface in one module. I redirect the dependencies to the interface, etc. That's quite a predictable step. The other benefit, I guess, let me just go back to, let's say this is still here, and I'll do a refresh here. There's that MAC address is still there. So in general, this represents a category of problems. They come up as red here, they're listed down here. I can navigate to them by clicking here. These are things that need fixing. I've got a team or a couple of guys that are going to be working for a couple of weeks or a couple of months creating this new module. And that's what they're going to be focused on. But in the meantime, I have another 20 guys who are doing bug fixes and feature development. I don't want them creating new violations of the target architecture while my guys are working on the target architecture, because then I'll never be finished. So another important part of the workflow is that the feature team, the feature developers, also use this view here, so that if I'm now a feature developer and I create this new machine ID dependency here, I will at least get a warning that I am using, at the moment, I'm using let me refresh. You can see here, I've got this new violation here, machine ID. Although, you see, here's the key point, is that license exception here is actually currently still inside core, and it's using something else that is still inside core. But what I'm viewing here is the target architecture, and therefore I'm getting a warning that this is a violation to the target architecture here, and I need to watch out for that. And if I kind of expand that there, I can see it in a bit more detail here. Here's my target. This is my new, as yet not created target module here. And within here, I have this dependency has now been created back to something else in core, okay, which is something in util here. There's this dependency here inside the license thing here. There's this new dependency I just created to machine ID. If I was viewing this through the lens of the current codebase, I wouldn't know there was a problem. But because I'm now viewing this through the lens of my target architecture, which we're planning to move to, I know, although it's not there yet, if I do what I'm about to commit, if I actually committed that, it would make life very complicated and difficult down the road for the guys who are moving the code base to the target architecture. So there you go. That's quite an elaborate use case, and we can certainly drill in it a bit, but I wanted to give you the flavor for the kind of things you can do with restructuring. I hope that's kind of served the purpose there. Next, we will have a look at the speccing, and you'll see how we can tie in the specifications. We can define them in Studio in such a way that they can be picked up in Workspace, and add a layer of checking above the simple, what we've looked at so far. In a way, this module stuff is a type of speccing. We're speccing a target architecture where we have specced that the dependencies are going to go from the core to the licensing and not from licensing to core. So we sort of lifted the lid on that. So I'll elaborate a bit more on that next. And we'll also look at how we can adjust the layering and even assign colors to areas of the LSM, just to make everything a lot more easier to understand, but also at the same time checking more rules in a proactive way rather than a reactive way.